Okay, we're here just looking at another simultaneous equation example. We have 3x minus 2 over 4 minus y minus 3 over 2 equals minus a half. Down the second line we have 2x plus 4 over 3 plus y plus 1 over 4 equals a quarter. So we're just going to identify the lowest common multiple, lowest common of 4 and 2. So we're going to try and eliminate the fractions straight away. So you multiply the first line by 4. Okay, so that gives us 4 times 3x minus 2 over 4 minus 4 times y minus 3 over 2 equals minus 4 times a half. Okay, now when we have a minus and you're multiplying by something, technically that should be plus 4 times minus that fraction. And if you think about it, when it says minus and a fraction, what it means is there's one of those fractions. Okay, so really what we're doing kind of is we're saying plus 4 times minus 1. And that's where the minus 4 comes from. Same with minus a half. There is one of those. So, and when the negative sign isn't attached to a specific part of that fraction, then this is good. It's a good practice to get into. So our first term, we have 4 times 3x minus 2 over 4. 4 divides into 4 once, so that leaves us with 3x minus 2, or 1 times all of that. Second term, 2 divides into minus 4, minus 2 times. Okay, so that leaves us with minus 2. So it's always a good idea just to do that one step, especially where there's a negative sign involved, is to just write out that. So we could do that at the first term as well. It's 1 times that minus 2 times that equals 2 into minus 4 goes minus 2 times. So we're left with minus 2 times 1. Okay, and you might say that's kind of a waste of time, but most of the mistakes that we see in these ones are where people forget the minus sign or don't do it properly or try and do a couple of steps together. Okay, so that leaves us with 3x minus 2, because 1 times 3x and 1 times minus 2 is that. Minus 2 times y is minus 2y. Minus 2 times minus 3 is plus 6. And then on the other side, we have just minus 2. Okay, now we're just trying to put like terms together. So we have 3x minus 2y plus 4 equals minus 2, because minus 2 plus 6 are like terms. We put them add them together, get plus 4. Now, normally we tend to try and get the constants on the right hand side, so we end up in this case with minus 6. So 3x minus 2y equals minus 6. Okay, so we're just going to park that. That's line number 1. So we've tidied up line number 1. We'll leave that and we'll go and look at line number 2. So line number 2, we have 2x plus 4 over 3 plus y plus 1 over 4 equals 1 over 4. So the lowest common multiple for this one is 12. Okay, so we're going to multiply everything in the first line by 12. So we're just going to come down here. So we're going to multiply everything by 12. Okay, so we have 12 times 2x plus 4 over 3 plus 12 times y plus 1 over 4 equals 12 times 1 over 4. Okay, so that gives us 3 into 12 goes 4 times. So we have 4 times 2x plus 4. 4 into 12 goes 3 times. Don't be tempted to multiply these out as well as dividing them. Do you understand? Don't be skipping this step that I'm writing out now. Okay? For the sake of a few 10 or 20 seconds, this is where most mistakes are made in these first few steps. So now we expand out the brackets. 8x plus 16 plus 3y plus 3 equals 3. And again, we identify any like terms before moving any further. So we have 8x plus 3y plus 19 equals 3. We have 8x plus 3y. We're going to take 19 from both sides just to put the constants on the same side as the previous one. Okay. So now we have tidied up that. So this is line number 1 and line number 2. So we have 3x minus 2y equals minus 6. That's line number 1. And line number 2 is 8x plus 3y equals minus 16. Okay, so now we kind of almost start from scratch again. We look at the two lines and we say, okay, we can't use a substitution method here. We can, but it's not as straightforward. So the best option here is the elimination method. The elimination method. So we either decide to eliminate the x's or the y's. And again, there's no advantage to doing one or the other in any case, but in this case, you're trying to say, okay, which is the most straightforward? So I would say we'll eliminate the y's, because if we multiply the top line by 3 and the bottom line by 2, we would turn the top line y's into minus 6y and the bottom line into plus 6y. Okay, so we'll do that. We have 9x minus 6y equals minus 36. On the bottom line, we have 16x plus 6y equals minus 32. Okay, and we're going to treat this now like a sum. We're going to add these together. 25x minus 6y plus 6y is 0y, so we eliminate them. Minus 36 minus 32 is minus 68. Okay. Oh, my bad maths right there. Minus 18. So that's minus 50. Okay. So then we divide both sides by 25, so we get x equals minus 2. Alright, not finished yet. We still have to then go and work out our y value. Okay, so we can just take the one that we just worked out there. 3x minus 2y equals minus 6. So 3 times minus 2 minus 2y equals minus 6. Minus 6 minus 2y equals minus 6. We're adding 6 to both sides. That leaves to minus 2y equals 0. So dividing both sides by minus 2, we get y equals 0. So our answer, our final answer is minus 2, 0. Okay, we want to verify that that's correct. So the best thing to do is to skip all the way back up to the original question, minus 2, 0. So if I put minus 2 in for x and 0 in for y, would this turn out to be true? So we're looking at the very first line here, 3x minus 2 over 4. 3 times minus 2 is minus 6. Minus 2 is minus 8. Divided by 4 is minus 2. Does that give us minus a half? Yes. Okay, and then same when you put in minus 2 on the second line and 0 minus 2 for x on the second line and 0 for y on the second line. Does that give us a quarter? 2 times minus 2 plus 4, so that ends up being 0 there at the front, or at the first term, and then we have 1 over 4 equals 1 over 4, so yes. Okay, so it fits into both of our original equations, so that means that minus 2, 0 is the solution in this case.